Hi, welcome to the final exam review examples, part A. You'll notice in each of these review examples, we're going to have two of each type of questions. We're going to have an A version and a B version. I'm going to go through and just work on the A versions so that we can talk about how to use your review when you're taking your actual exam or even when you're doing your practice test. So first we're going to start off with just 1A, 2A, 3A, etc. And then in the next video, we'll come back and look at the B problems. Okay, so starting with 1A. The triangles below are similar. What is the perimeter of the second triangle? Okay, so it does tell me they are similar, which means they have a scale factor between them. And remember, your sides and your perimeters, your S and your P in your SPA table, they match up. Now, when we did this, we didn't create the SPA table because we hadn't included area. This is way back from Unit 5. So we just noted that the perimeter had a similar ratio or the same ratio as the sides. So when I compared one triangle that I put an up arrow in with the other triangle that I put a down arrow in, so I would remember always to put this in a numerator, always put this in a denominator. When I compare the side 4 over the side 8, I could reduce that if I wanted to and get it to 1/2 and work with smaller numbers. And then my up arrow, the perimeter 1 is 17. And my perimeter 2 for my down arrow, that's what I'm trying to find. So then in this case, what we're going to need to do is we're going to need to cross multiply. All right, so when I cross multiply, the first thing I'm going to do is grab my calculator, which I already have open, and I'm going to do 4 times x equals 8 times 17. Oops, 8 times 14. 8 times 17, which is 136. Okay, so then I'm going to divide both sides by 4. And I can see that I'm going to get an x value that equals, 136 divided by 4 is 34. So that is my perimeter for the second triangle. Okay, let's move to 2A. On 2A, it's asking me to find x. Now, when I do this, I'm just going to be looking. I notice I have an isosceles triangle. And when I have an isosceles triangle, the first thing that I remember about an isosceles triangle is if I draw on the altitude, well, other than two sides are the same, if I draw on the altitude from the vertex angle where the two congruent sides come together towards the base, that altitude divides the base into 2 equal pieces. So if the whole length along the bottom is 10, then this is 5 and this is 5. Anytime you have two sides that are the same, that's going to work. Once I do that, then my focus changes to just one side of the triangle because I can see it is a little right triangle where I'm trying to find a leg. And I know when I'm trying to find a leg, I am going to square root with the difference of the hypotenuse squared minus the leg squared. Okay, so in my calculator, to find my value of x, because x is the leg, I just need to do the square root of 12 squared minus 5 squared, and that gives me this long decimal, which I'm going to round to 3 places because I wasn't given further instructions about rounding. So 9.0, I'm going to go with 9 because that 7 is going to bump it up. 9.0, sorry, I lied. 10.909. I missed the first part of that. 10.909 units is my value for x on 2A. Let's go look at 3. A captain's GPS tells him that he's 40 meters away from his treasure. He walks 24 meters west. The GPS now tells him that his treasure is south of him. How far does he need to go? So when I look, I can see he went west and then he went south, which means he must have made a turn of 90 degrees. If you're going west and then now you're going south, you made a turn of 90 degrees. And I'm trying to figure out, what is this length right here? How far south does he still need to go? Okay, well again, just like the last problem, I'm trying to find a leg. So I know I'm going to subtract inside my square root the hypotenuse squared minus the other leg squared. So that leg, which I've labeled x in my picture, is the square root of 40 squared minus 24 squared, which gives me, oh, it's a nice even number, 32, and my units here are meters. Okay, let's go look at number 4. Number 4, find the value of x. Make sure your calculator is in degrees. Okay, when I see this warning, that tells me we're probably going to be using SOHCAHTOA. We're going to be using our trig functions. Otherwise, we wouldn't need to worry about being in degrees. So I'm going to go ahead and write that down. Don't forget, if you have forgotten that, I do have in Schoology, under resources, I can open my formula chart. And in my formula chart, I do have the rules for trig, in case I have forgotten them. I have my right triangle rules. I have those Pythagorean theorem shortcut. When I'm looking for a leg, I'm subtracting. And then I have my 30, 60, 90, my 45, 45, 90, and then here my trig, SOHCAHTOA, is all right there at my fingertips in Schoology for me. Okay? All right, so I'm going to make sure that my calculator is in degrees. I'm going to click mode, and I can see it's not. So I'm going to arrow down, highlight the degree, and hit enter. And now you can see radian is unhighlighted, degree is highlighted. And then to leave, right here in blue, it says quit. So second mode, and I'm right back to where I started. Okay? All right, so now, remember the first thing we want to do when we're doing these problems, to find this side x, I'm going to put my smiley face right here. This is where I'm standing. And then I'm going to label across from the right angle is my hypotenuse. So I'm trying to find a hypotenuse. And then out of where I'm standing, one side's always your hypotenuse, the other side's always your adjacent. I already had the hypotenuse labeled. Then the side that's not coming out, the side you're yelling at, you have to yell at it because it's on the opposite side of the triangle, so it's far away from you. It's all the way on the opposite side. Okay, so then we circle. I'm trying to find the hypotenuse. Check and check. I know the opposite. Check and check. So the trig function I want to use is sine. The sine of the angle equals O over H, my opposite over my hypotenuse. My opposite is 10.8. My hypotenuse is x. Okay, so then to get the x by itself and not to be in the bottom of a fraction, I'm going to cross multiply by putting this side over 1. And when I cross multiply, I'm going to get x times the sine of 57 equals 10.8 times 1. That's easy, just 10.8. Okay, then I don't have x equals, I have x times. The opposite of times is dividing, so I need to divide out that sine of 57. Okay, so then x equals 10.8 divided by the sine of 57. 10.8 divided by the sine of 57, and then remember it opens up parentheses for you because it knows you want to put something by sine, so we should close it, put that seatbelt on, and when I hit enter, I get 12.878. 12.878 when I round correctly. 1, 2, 3. That 5 bumps up that second 7. And these are units. Okay, let's look at 5A. 5A is also asking me to make sure my calculator is in degrees, but we've already done that, so we're already there. I know I'm going to be using SOHCAHTOA which means I need to figure out what angle I'm going to be standing at, the angle that I'm looking for. So this time I'm trying to find an angle. Remember, when you're trying to find an angle, you're going to do inverse. Coming out of my smiling face, one is the hypotenuse, one is the adjacent. The hypotenuse is across from the right angle. So that means the 10 is adjacent, and then I have to yell all the way across the triangle to the opposite side. So the two sides that I know this time, instead of a side I'm trying to find, I know the opposite and the adjacent. I know the opposite, I know the adjacent. So the trig function I want to use is tangent. But this time, because I'm looking for an angle, I'm not going to use regular tangent. I'm going to use the inverse tangent. And then it's going to open parentheses, and I'm going to put this ratio in the parentheses. So opposite over adjacent. My opposite is 11.9. Over my adjacent is 10, and that's going to give me that angle. It's going to work backwards to give me that angle x. So the inverse tangent. Now, if you notice, my little negative ones are here in blue. So I'm going to hit second and tangent, and it opens up that parentheses. It puts that little negative 1. 11.9 divided by 10. Close that parentheses, and when I hit enter, I get 49.95845.092. It says to the nearest degree, so that means to the nearest whole number. That's going to be 50 degrees. 50 degrees is my value for that angle. Okay, let's look at 6a. For the parallelogram, find x. Okay, so I do know I have a parallelogram. I don't know, no longer do I see that don't forget it to be in degrees, so I'm pretty sure I've moved on. Plus, I don't have any right angles, so I shouldn't be using trig. Okay, it's a parallelogram, which means I know that my opposite sides are parallel here and here, and here and here. And x is this angle that deals with this parallel line and this diagonal. So if I think about my rules for transversals of parallel lines, I know my alternate interior angles are congruent. So this angle right here is going to be congruent to this angle right here because they're alternate interior angles. So I don't really have to do much but look at this and know parallel rules. And I know that x equals 60 degrees. Okay. All right. 7a, the diagonals of a rectangle are perpendicular, true or false. Well, you know what I'm going to do? I'm going to draw a rectangle and just see what I think about that. Okay. And I'm going to make sure my rectangle looks like a real rectangle, not like a square. So I want it to be like a real rectangle. As close as I can get without a ruler and just trying to draw with my mouse. Okay, so there's my rectangle. I do know I have 90-degree angles in my corners. I know opposite sides are congruent. My sides next to each other are perpendicular. So if I were to draw in the diagonals of this rectangle, pretend that was a good diagonal, pretend that's a good diagonal. Look at my angles here. I know these vertical angles are the same. But are they 90 degrees? Are they the same size as these two angles? No, right? It looks like I've got two acute little angles and two obtuse angles. So my diagonals of a rectangle are perpendicular. Remember, that means 90 degrees. That is a false statement, and this is a counterexample. Okay, let's look at 8. For the isosceles trapezoid, find x. This one is going to be a great one if you have your review when you're working, because your base angles in an isosceles trapezoid, your diagonals are congruent, and your base angles, while not divided in half, they are divided into sets of equal parts. So if this angle is 45, then x is 45 degrees. Okay, let's look at 9a. Find the value of x in the kite below. Now, my kite is a quadrilateral, which means all the angles add up to 360 because it has 4 sides. And my side-to-side angles in a kite, my tip and tail, or my top and tail, are not going to be the same as each other. They're always going to be different, but your side-to-side angles are always equal. So if this angle is x, then this angle down here is x. The 4 angles in a quadrilateral add up to 360. So I'm going to take the 2 angles that I do know, my 110 and my 22, and I'm going to add them together. And then I'm going to take that away from 360. 360 minus 132 is 228. Now that 228 has to be divided evenly into these 2 angles. So I'm going to take that and divide it by 2. And I get that x equals 114 degrees. Okay? And 2 more. Let's look at 10. P is translated such that P, 2, 7, translates to P prime, negative 4, 15. What is the coordinate notation for the translation? All right, so coordinate notation, in case we have forgotten, if I look at my formula chart down here, my transformation or translation, xy goes to x plus or minus a, y plus or minus b. So it should look something like this. So xy is going to go to x plus or minus a number, y plus or minus a number. Okay, so xy translates to x, and then let's see, if I'm going from 2 to negative 4, I'm definitely getting smaller, right? Because I'm going from a positive number to a negative number, so I'm decreasing. How much am I decreasing to get from 2 down to negative 4? I'm decreasing by 6. Then for y, I'm going from 7 all the way up to 15. So my y to get from p to p prime is increasing, so I'm adding to y. How much am I adding to get from 7 to 15? I'm adding 8, right? Yeah, 8. So this is my coordinate notation for the translation that will take p to p prime. Okay, let's look at the last one, number 11. If the figure below is reflected across the y-axis, what will be the coordinates of x prime? Well, first let's figure out where is our y-axis. So my y-axis is going to be this line right here. That's my y-axis. So if I am reflecting across the y-axis, and I have this whole figure, but I'm really only worried about where is x prime going to be. So I'm only really worried about where x is to start. X is 1, 2, 3, 4 squares away. So it's going to be 1, 2, 3, 4 squares away right here. So x prime will be at the point 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. So x prime is at the point 4, 5. Now, reflection across the y-axis, if I were to look at my formula chart at reflection y-axis, I can see xy goes to the opposite of x, y. If I look at my original x point, it's the point negative 4, 5, right? Negative 4, 5. So the opposite of x, negative 4 becomes positive 4, and then my y doesn't change. So you can either use your graph or you could use those transformation rules either way. Okay? In the next video, we're going to look at how can we use these answers on the left-hand side to help us if we've forgotten how to do them when we get to the new problems on the right-hand side or on our practice test or on the actual final. All right, so come on back for that next video. Thanks so much for watching.